Well, greetings everybody once again. Welcome to lesson number 12 of trigonometry for students and surveyors. As promised, we're going to get to coordinate geometry. This is going to be called latitude and departure. Now this is a little bit geared towards surveying, but I believe students will gain a lot of appreciation and understanding of how surveyors use trigonometry in their everyday work. And then it'll also, make it so it's not academic to you, and it'll be more practical type of a math here. So let's get with it. So what I've done is I've drawn in. This is called a traverse. We'll go step by step by step. Let's see. We're gonna do coordinates, bearings, back bearings, so on and so forth. Let's see here. So where do we start? We'll start at number one. These are angles. These numbers represent the angles. 7, 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. And that's where we go from there. Now we're going to start here. We're going to start here and we're going to traverse up to here. This is going to be our foresight bearing, or foresight azimuth. And this is going to be our distance, 830 feet, 30 centimeters, meters, whatever you want to convert it to. If you can, it doesn't really matter. And then we're going to figure out as we go. One thing I want you to keep in mind is we use an instrument like this. It's a robotic station, or it's a total station, or it's not necessarily robotic. But we turn angles, but everything we base on is based on north, south, east, and west, just like that grid line on the Cartesian coordinates, on the rectangular coordinates, on latitude and longitude. Everything is based on that. So everywhere, even though these come up to an angle, once you're sitting there, your instrument is going to know that you're north, south, east, west. This always is oriented this way. You don't change north and south to match these lines. The lines match whatever bearing or azimuth you're at. Another thing, just that I can put these away, these are two identical protractors. When you're sitting on a point, let's just say right here, you can see I've got that north, and then you're going to backsight. And let me see. Maybe this is a little bit easier. That's the same thing. You're going to sit on here with your instrument, and you're going to backsight back to this point here. You're going to come around, and then eventually close in. You're going to sit here, and you're going to backsight this angle. Well, that angle, right now it's saying 330. I think I have something different on here. You have a backsight angle, and then you have your gun. And your gun knows where you're at. Your instrument, you're telling it where it's at. It doesn't know what bearing it's looking at. You're just saying you're at this coordinate. The gun knows that it's at a coordinate, but it doesn't know where to start looking or how to calculate any angles until you give it some kind of a bearing to reference off of. So now you're saying you're backsighting 6. Well, it knows that 6 is on 330 degrees northwest, or 330 degrees azimuth. That would be that would be a 30 degrees if that was a northwest bearing, 30 degrees north. When you set your gun now and you start measuring angles, you zero your gun. So I'm going to put that there. This is just an identical one, and now you're putting 0. You got 1 going up. You got 0 on your backsight, and then you can start measuring angles. You don't have to try to keep track of bearings. Get off of there. Well, that's where it's going to stay. You zero your gun there, and then you measure an angle back to this line. I smeared that all up. Okay, my protractor experiment didn't work all that great. And put that in. All right. Maybe someday that'll come off. Maybe guess it's part of the, let's just put it where we like it. Looks pretty there. Yeah, we just put it right there. All right. All right. So let's get started here. Got to have a calculator. Before we get going now, we're gonna create coordinates. Latitude and longitude with your phone or whatever kind of a device you might have. You might have a Garmin device. I think I have one over here. I have this InReach Mini 2. It's for like backpacking. It's emergency. You can call out. It can tell you what your coordinates are. These go to latitude and longitude. Latitude and longitude are polar coordinates. They're not plane. We're dealing with plane coordinates. So these can be real coordinates based on latitude and longitude, which we convert surveying into northings and eastings. And you recall our geometry before. We had our quadrants. The northeast quadrant was positive, and the southeast quadrant was a positive easting but a negative northing. Our southwest quadrant was negative, and our northwest quadrant was positive northing and negative easting. And our Cartesian rectangular graphic we had over here the other day, we have 0 going here, 90 going up, and then I showed you on the other one, on the spherical one, on the circular one, we have 90 at the top. That's the zenith angle, going down to, or 0 at the top, going down to 90, 180, 270, and back, or 0, 90, 0, 90, 0 if you're using bearings. Okay, that's kind of a refresher of that. What we haven't done too much, we also did some elevations using the original triangle, using a vertical angle to solve the distance of a tree and to solve our 3, 4, 5 triangle. The opposite side of our angle was 3, and we got that by sine, or by tangent, but by sine. And I showed you on the other diagram that we use cosine because we're using 90, and that everything was 90 degrees off of the other one, of vertical to zenith. They're 90 degrees. Sine and cosine are inverted, so we use cosine now to find that opposite elevation. So I'm going to give you distances here, all the way around here. We have the distances, we have everything figured out. We're going to work these up. Just keep in mind that these distances are horizontal distances, and all of our horizontal, every time we measure something with a gun, we're measuring at an angle. Nothing's ever flat. Nothing is ever, almost nothing ever is 90 degrees. Somebody goes out and gives you a shot, or your backsight, there's always going to be some slope to it. And the data collector automatically converts everything to horizontal distances. And the whole point of this class and everything, so you can learn to do that. What's going on in your data collector? How's it doing that? And that's what we're going to figure out here. But for the sake of this is going to be a 2-dimensional. This is just going to be X and Y. We're not dealing with any vertical yet. We're going to do an X and Y, a flat plane grid to start with. We're going to run coordinates around here, angles, bearings, all the stuff around here. And then we're going to use zenith angle, and we're going to start converting slope distances. We're going to start looking at that and using the vertical component of it. Rise over run, slopes for pipes, slopes for this or that. Then we're going to combine the two, vertical and horizontal, to make a complete XYZ coordinate, to make complete XYZ coordinates. Wherever distance we turn, whatever angle we turn, we'll be able to calculate XYZ coordinates, northing, easting, and elevation. Okay, so let's get started. As I said, we could put a GPS coordinate on here, a real coordinate. They're in the thousands or millions, whatever they are over here this far where we're at. And you'll notice that they're a negative, they're written hours, minutes, seconds, or they're written in a negative, the easting for over here, considering we're west of the prime meridian, so we're in a negative, but we're not going to worry about that. Same with northing. If we had those converted to northings, they'd be very high numbers. Well, we don't need to do that. What we're going to do is we're going to create an assumed coordinate. It doesn't really matter. They just have to relate to themselves. The assumed coordinate. Now, let me show you what I'm kind of talking about here. Whenever you have a plat, if you live in town and have a street, you live in an urban area and you have a street, or even out in the country, you'll notice out in the street, more than likely you'll have monuments. And those monuments indicate the bearings between the two monuments, whatever, like this is called Meadow Road. There's a monument there and a monument there. These show the bearings, and I said plat maps are always in bearings. So I'll just go ahead and use that terminology for now, not azimuth. And when I do the math, I convert it to azimuth. I think that's the easiest way. So this is a bearing from this monument to this monument, and this is the distance. And this is basically how section control is. Sections are a mile square. They have bearings and distances between them, or between them and the quarter corners, which are half a mile. Sometimes there's a break in the bearing. But this is a plat map. I think I'll bring it up for you. I've got some writing on there. And it's basically, you've got a main road out here. This plat has been built off this main road, and here's your boundaries. Here's your lots, lot 1, 2, 3, and here's your bearings on the lot, your distances, bearings, and it's all related to this is a filed plat map. So if a neighbor here said, well, I got to call the surveyor because I think my neighbor is building a fence on my property, they'll call out, and the surveyor, all they need to do, they'll never have, maybe they had nothing to do with this plat, but they'll have a record of the plat map, and they can just start anywhere they want, probably start at one of these monuments and call that an assumed coordinate system. And they'll just put all this, they'll start out with a coordinate, then they'll put in bearing and distance to the next monument, and so on to the next monument. They'll come across here, whatever that distance is, come across there, and they'll go into this plat and just start coordinating all these bearings and distances to coordinates. And then when they come into then when we come in, that'll be all processed. We'll get a coordinate list. We'll come in as surveyors and sit on this monument, maybe backsight that monument, check to a couple of rebars. Oh yeah, that looks good. And then we'll go into this guy's yard and make sure we'll look for his property corners. We'll put line stakes in, and we'll be assured by making our checks and our distances compared to the plat, we know where we're at. That's the mathematical certainty of trigonometry. That's what really makes it really nice. This is the same thing here. This is my area here, and I surveyed my own property. I just came off of these monuments here, calc my boundary, checked my rebar, found them pretty much right where they're supposed to be. It depends on what you're shooting. Rebars on your property should be within 2, 3, 4 hundredths, or that would be, say, 1/4 of an inch. Sometimes it'll be a 1/2 inch. And if you find something that's a little bit wonky, you note that. You don't set a new one, you just note it. Unless it's really off, then you can set a new one. You can probably assume somebody has messed with it. But that's too much surveying. We're not going to get into that. But I'm explaining that because what we're going to do we're going to use assumed coordinates, just like you could use here, probably would use here, and so on and so forth. So we're going to use assumed coordinates. Now, where do we start with that? We're going to start at 1, and a section is a mile by a mile, so that's 5,280 feet. So it's quite common for surveyors to use their starting coordinate, assumed coordinate at 5,000 by 5,000. It doesn't matter what you started at. It depends on how big you're going to go. You could go 10,000 by 10,000. Now, why don't we go on the Cartesian coordinates? We had 0 by over 0. And then as soon as you went up to the northeast, everything was positive. To the southeast, you had positive easting, but you're getting into the negative numbers when you go to the south. When you go to the southwest, you have a negative number by a negative number. And I think we charted all that stuff out. And then up here we had a positive northing and a negative easting, and you're in negative numbers because you're starting out at 0. Well, here you start out at 5,000, and now even if you go to the west, you're subtracting, you're using a smaller number. I mean, you're subtracting because you're going into the negative, but because you started out clear up at 5,000, you're never in the negative numbers. You're just in, say, 4,900. If you go 100 feet west, you're 4,900 instead of 5,000. You're not into a negative 100. And that's why we use assumed coordinates like that. So I'm going to write this down here. We'll go 5,000 over 5,000. And that's northing, and that's easting. That could be latitude or longitude either. They'd be different numbers, but it's very similar process to that. So we're starting there, and our idea is to travel around and come back and try to match that number. That's the whole point of surveying, or one of my greatest challenges surveying is trying to reduce your residuals to zero. Always try to get as tight as possible. Make sure your instruments are all calibrated constantly. You're always looking to try to get perfection. You're chasing perfection. Okay, so what we're doing now is we're going to carry coordinates, and we're going to put a set of coordinates on this point here. I keep smearing my board up. Now remember, on that board I had over there, we said the northings are cosine and the eastings are sine, and we had you do that. We went with the 45, we went with a 235, what did we do? 335, 225, and a 115. I think that's how we did that. 315, sorry, and a 315. So your cosine over here is positive and your sine is positive. Over here your cosine is negative, your sine is positive. So anyways, your sine, let me just write this in here. Your northing is going to be your cosine, and your easting is going to be your sine. There, that'll help. Let's just work with that. All right, now, and these are horizontal distances. And this is the bearing, or the azimuth. So let's just throw this first one in here. Now, as far as the calculators, I use my HP, and I showed you how to use memory, but we'll go through that again because it's kind of important here. What I like to do is put my calculator is laid out. Well, so is yours. So I have 0, and that's going to be my angle, and I showed you that's my symbol. Now straight up is 7, and that's north. So that's where I put my cosine. Straight east, so that's my northern. Straight east is 3. I'm just talking about the keys on my calculator, and that's where I put the sine. Okay, so here's where the angle is, or the bearing, and that's going to be the number 7. So you want to pick some keys out that make sense, and I do this because my northing is straight north, my easting is straight east, and then here's my angle is right in between them. So my angle's down here, my northing is at 7, my easting's at 3. Now, so you have that. So we're going to enter in 5,000, store 7. So I have, that's 5,000 now. And then we're going to also hit store 3. Okay, so, and now we want to go, let's go with 65, 10, 12. First of all, if you're using the free HP 42S, the download for your iPhone or for your Samsung, you have to add one extra step when you hit store, let's say store 7, you have to also hit enter. Same with recall. You'll have to recall 7, enter. Other than that, they're exactly the same. So that's how you enter. Now we're going to recall just to double check. Recall 7 is 5,000. Recall 3 is 5,000. All right. Now we're going to put in, this is a bearing, 65, 10, 12. It's not written as a decimal. and neither are they on your plat maps. They're written as bearings, so you have to convert all these plat maps to decimal, and you know how to, by now you know how to do that on your calculator. So on the HP 42S, the free, I think it's the convert is shift key, and I think it's the 5 key. I don't have my other phone in here with me. So that's how you convert back and forth, and you want to convert HMS, hours, minutes, seconds, to HR, and that's decimal. When you're all done, you convert back and then just reverse these. Okay, so then that's your final answer. So we've got our northing loaded, we got our easting loaded. Now let's load up our 65, 10, 12. Let's go 65 degrees, 10 minutes, 12 seconds. And now we want to convert that. And I got 65, 17, and I'm going to store that as 0, which is theta, 65, 17. So now I've got that in there. I got that there, I got that there. And now we have 830. Now that's an even number, so we don't need to really store that. It's an easy number. If we had it point, we'd probably want to store that, but we won't worry about storing that right now. Okay, so we start with, what we're going to do is we're going to calculate this, how far north this is and how far east this point here is than this one here, 5,000, 5,000. So we got our 65, 10, 12. We convert that to 65, 17. Now let's start with cosine, because we're going to do our northing. So cosine. So I got a 0.4199. And now we want to take the distance, and that's horizontal distance. That's not slope distance. That's already been converted back or reduced back to horizontal distance. So now you want to go times 830, or in RPN, reverse Polish notation, 830 times. So now I have 348, 53, 97. And remember, your decimals should be at least 4 places just to create that accuracy. Now, one of the things, I'll do another show. 348, 53, 96, 88, 965. So that's why if you store that, when you get all done, you're going to be a little tighter than if you only store the 4 decimals, or if you only use those. So now we're going to hit, so that's 348 feet north of this. So we're going to go store plus. Now you want to hit store plus whatever your northing is here, which is 5,000. So we're going to go hit 348, 5397, and we're going to hit store plus 7. Now recall 7 is 5348, 5397. That's our new northing over here. So I'm going to write that down. 5348. 5397. Okay, now we're going to go easting. Okay, let's do the same thing with the easting now. Let's just clear all that out. If you have a big mistake, usually when you're doing this, if you have a big mistake, you probably accidentally overwrote your memory. So if you just hit store 7, it's going to take whatever's in 7 and wipe it out. It's just going to give you that 348 number, and that's going to be your new number. And if you don't keep checking as you go, when you get to the end, you're going to like, this doesn't work. So make sure you hit store plus 7 each time, and then you could hit recall. So if you have a big mistake, that's probably what you did, is you've overwritten your memory. You didn't just add to the memory. If you have a small mistake, the smaller mistake, it's probably because you've, on one or the other of these, you forgot to convert, or you didn't convert, and so you've added this number instead of whatever that other decimal number is, which I'm going to recall it right now. That one is 6517. So you want that same bearing again. And now you want to hit sine. This is the decimal version, 6517. So now you want to hit sine, and that is 0.9076. And now you want to hit 830, that same distance, and times, or times 830. Now you have 753.2729. So we're going to add that to that. So now we're going to go store plus 3. Now we're going to recall 3, and we have 5753.279. Everything's looking good. So 5, 7, 5, 3, 2, 7, 2, 9. There's your northing and easting for number 2 now. And that's the simplest way that I know of to do latitude and departure. So now, so what have we done? All right, that's good. We're going to go do a whole bunch more here. I don't know if we're going to get all the way around this. I kind of doubt it today. We'll probably take a couple lessons to do that. But what have we done here? Let's go with this here. We've gone 348 north and 53. So what we've done, because we've used cosine, we've done this. And that's the north, and then this is, and then we went east. So let's just look at here. Okay. This is supposed to be a right angle. That's why I say you use that symbol if you mean that to be a right angle, but it might not necessarily look like one, because it looks like I got my line slanted to the right, to the east just a little bit, but it's supposed to be a right angle. So we've gone 348 feet this way, and we've gone 753 feet that way. So that's our right triangle, and this is why it's a cosine. It's because we're using a zenith angle. Okay. Now, if we were doing the vertical angle, like with the 3, 4, 5 triangle, it would be like this. This is our rectangle. That's why they call it polar rectangular. So on this side, it would be 348. Now this would be if we were doing a vertical angle, if we were using this as 0 and this as 90, but we're using this as straight up. Oh, it fell down. I'll never get this off of here. I don't know what I'm going to do. All right, well, fine. Just stay there then. Okay, so that's, okay. That's how that's done. That's what's going on there. Every one of these is going to be a triangle. And now this one angles back to the northwest, so you're going to have a small triangle here, and it's going to be a negative easting. You're going to have your northing is going to be almost the same as a northing, and it's going to be easting. But let's not get ahead of ourselves. Let's just do the next one now. Okay, so the next one. Let's just go with the hold on a minute here. Let me get this out. All right. We're going to go with our bearing here. 345, 1827. That's small. Okay, I'll put those up there. 345, 1827. And our distance is 730. Okay. So now we know we would do the northing and the easting. So we're going to figure out our northing and an easting. We have that. So let's just go ahead and do that, and then we'll do some more on that. So we have our new northing and easting stored under 7. So now this is now 7. So this is going to be 7. So check your data collectors, or check your check your calculators. So you should have this number stored as your northing, and that number should be stored as your easting because you carried that over. So now let's go and enter this new one, 345.1827.1827. Now that's your azimuth, so we're going to convert that. And that's 345.3075, and we're going to store that as 0. Okay, and that's stored as 0. All right. Yeah, well, we just have to remember that that's always stored as 0. All right, so now we have that stored. Recall 0, 345.3075. Now we want the cosine. Let's go with northing and easting. Remember, that's cosine. This is cosine. This is sine. Northing is cosine. Easting is sine. This is 190 degrees opposite if it was vertical angles and vertical coordinates in the rectangular system. All right, now let's go recall 0, 345.3075. Now we want the cosine of that, 0.9673. Now that makes sense because it's almost 1. It's almost a 1-to-1 ratio, and you can see 345, 360 would be perfectly north, so it's 0.96, so it's quite a high number. So we want the cosine, and we want to multiply it times 730. So again, we didn't save 730 because it's an even number, so we just go 730 times. And we have 706 feet, 0.1297. So now we're going to add that to our northing, which is number 7. So we're going to go store plus 7. And we're going to go recall 7. So we've added that 700 and something feet to this number here. So now we have 605.4.6694. And now we have that stored there. Okay, now we're going to recall that angle, that bearing, that azimuth. I say those things all. I transpose those all the time. So we want to do that. We want to hit sine, because now we're going to figure our easting. Now we're going to hit sine, and you'll see that it's a negative number. It's a negative 0.2536, because we're going to the west. That's the negative direction. So now we want to hit 730 times, or times 730. And that's 185 degrees, or 185 feet to the west it went. So now we're going to add, it's a negative number, it's a negative 185, so we're going to add that to our easting here. And we're going to go store plus 3. And now recall 3. Let me see if I have that right. 5568122. So here we are. 556.8.122. That's that's our coordinate for that point there. So as you can see now, especially you surveyors, you've turned thousands of angles a day or several hundred angles a day. You shoot the asphalt, the curbs, the manholes, property corners, and that's what your data collector is doing. It's figuring out what that foresight bearing and that distance is from wherever it's at, and it's adding coordinates to whatever coordinate it started out as. And it started out at 5,000, 5,000, 5,000. So that's where we're at there. Now let's go ahead and do We'll go ahead and do the next one. We'll go and do 4. And 4 is 52, 21, 14. And the distance is 570. Okay, 570. Okay. So now we're going to go put in 52, 21, 14. Convert it. 52, 35, 39, and store that as 0, or whatever you store it at. Store 0. Now I didn't say plus 0, I just said store 0 because I want to overwrite these bearings. I'm putting in the new bearing slash azimuth. So 52, now we want to go with, we'll go with cosine. And we're going to go up here. We'll go northing, easting, call that cosine, and sine. So we're going to go sine, we'll recall that angle, and then we're going to go cosine. I got 0.6108, and now we want to go 570 times 348, 1461. Now we want to add that to that one. So we're going to go store plus 7. Recall 7. 6402 8155. Okay, recall that angle or that bearing again, 52, 35, 39. That's the decimal version. You want to hit sine, and that's 0.7918. So you can see that it's a positive number because it's going off to the east. That's positive direction. And now we want to 570 times. We got 451 feet, and now we want to add that. 451, 1321. Store plus 3 and recall 3. 6019 4471. 6019.4471. And that's that one. That's that guy right there. Cosine, sine, northing, sine, easting. And that's that one right there. And that's pretty much how you do that. And again, we would have these same triangles here and there if you wanted to superimpose those in there. This one would be, let's just do this one. I think I could probably do this one. Okay, I'll just do this one just to show you. I don't think I'll obscure too much of my writing. So we're going northing, easting. Okay, I can do a better north than that. So we've gone, let's just do this again. We will go recall 0, cosine 570 times, we've gone 348 feet this way. I'm just rounding it off. Now we'll recall 0, sine, and 570 times, we've gone 451 feet this way. All right, so that's what's going on. That's your polar rectangle. You have, and again, you could always do another rectangle down here, another triangle down here. So that's what's going on. So now you know. So at a lot of these calculators, they have that polar rectangular feature. So there you are. Now, how did we get there? How did we get to that? Well, let's go and check that out. So we started here with this angle. How did we get that? Well, we're going to have to start here because I'm not giving you any information there. I could, let's see, I want to do that, 99. We'll just start here at 2. So we're going to start here at 2. You'll see in a minute why I'm starting here. We're going to start here, and we're going to figure this one out here. So you're starting here with this coordinate, and now you're backsighting that. Well, your foresight was 65, 10, 12. So you need your backsight, because what we're trying to do is figure out, we're trying to figure out this angle now. Because that's where that foresight came from, was taking this backsight and adding this angle to that foresight. So those didn't just show up out of thin air. Those came from measuring this angle to your foresight. So your gun would be sitting here, you'd have a backsight there, you'd have a new tripod set there, and you're turning an angle to it, and then you're recording everything. Well, what's the angle? Well, I'm going to work kind of backwards because we got our two numbers. For now, I'm going to work backwards. So 65, 10, 12 is that direction. Well, you need your backsight. So we're going to go 65, 10, 65.1012. All right, convert that. Now we want the backside of that. So that's going to be 180 plus. And that should be 245, 10, 12. That's the bearing. That's the actual bearing. It's 245, 10. So that's right. So we have 245, 17. That's the decimal. And let me write that in here. This is going this way. Let me write the back bearings in a different color. We'll write those in brown. 245, 17. And we'll go 245. It's actually, let me convert it, 10, 12, of course. Okay, 10, 12. That's your back bearing. So now you're figuring out the angle from there to here. And that angle, so now we're going to convert it back into decimal. So I've already written the angles down because we're doing this backwards now. The angle is 100.0815 to 3. So we got our back bearing, our back azimuth, 245, 10, 12. We've converted it back to decimal, 245, 17. Now we're going to add 100.0815. This angle is going to be 100.0815. That's HMS, hours, minutes, seconds. So we're going to have to convert that. We have our backside decimal in there, 245.17. Now we enter 100.0815, and now convert that to decimal. And now hit plus or plus that. And your new is 345.3075. If you convert that, it's 345.1827, just like it says there. So that was done first. The angles were put in, and then these bearings were calculated from those angles. So I already had the bearings written down. We were just going to do that part. We have done that. Now I'm showing you where that came from. So if you have a backsight, you have to do, this is the backsight. I need to do an arrow here. This is the arrow up there. So now I'm going to just erase this. We're just going to do, you just got to remember to convert. And that's the angle. 108.15. That's this angle here. That's the angle. 108.15. All right, now we're going to go up to, now we're sitting here. We've done that. We put our angle in. We've converted to a foresight bearing, 30, 45, 18. We've got a new coordinate. Now we're sitting at 3. We're backsighting 2. So we need to get our backsight in there. We're going that way, so we need a backsight so we can calculate this angle. I am going to take this orange off for now. I don't think we need it. I don't think we're going to need these anymore. You get the idea with that triangle where that comes from. Okay, same with this. Okay, we're going to do this one and then call it a day, I think. We're getting probably in our time limit. Now, we're here. Okay, so we're here at this coordinate here. Now we're going to figure out that bearing. So we need our back bearing. So our back bearing is 345.1827. That's our foresight bearing. We're looking backwards. Convert that to decimal. And then we want 180 plus, now we got 525, 30, 75, and now we want to go 360 minus. Okay, that didn't work. What are we doing here? 52, 21, 14. All right, I was talking, so let's just go 345.1827. Convert 180 plus, now 360, oh I say 360 minus is 165, 1827, that's correct. Let me convert that. That is correct. Okay, I forgot to add the angle. So the back bearing is 165. I'm supposed to do that in brown. $165, 1827. 165, 1827. That's that bearing. And that's that bearing. That's going that direction. Okay. Now we're going to add the angle to that puppy there. Number 3 is 247.0247. 247.0247, and that's this angle, like so. So always remember when you're surveying, you're turning right angles. There's probably places where you don't, or you can calculate you turning left angles. Everything is based on 360 turning right. So you're backsighting that, you're turning right angle to that one. So 247.0247. What's our back angle? Where we get that back one? 165.1827. 827. Okay, 165.18. 65.1827. Okay. And now we need to convert that to decimal. 165, 30, 75. Now we're going to add 247.0247 to it. 247.0247. Convert that to decimal. and hit plus. And we have 412, 35, 39, that's the decimal. But we know we can't go past 360, so we're going to have to subtract 360 from that, because there is no 412. 360 is the highest number, so 360 minus gives us 52, 35, 39, and we'll convert that to 52, 21, 14. Okay, so that's that. That's going that way. All right. So our back bearing, and we'll go there. We'll go 180 plus is 232, 35, 39. 232, 35, 39. Two 232.35-39 degrees minute seconds, and that's the back azimuth right there. Okay, now I think we got time to do one more. Let's do this opposite now. I'm smearing all my numbers. 570. Okay, now we're going to turn an angle, and we're going to go to 5, or I think we might be done for the day. See, we've started out, okay. Tomorrow we'll finish the rest of these angles and close back in, and we're going to turn a closing angle as well. This will be our closing angle, unless I started here. Anyways, we'll have a closing angle, and we'll be able to calculate our polygon. So let's review. We started out with assumed coordinates 5,000, 5,000. We made the number large enough so wherever we move on our plat, on our survey, on our big closed loop traverse, whether it's going around a block or 2 blocks or a whole city, you make it big enough so that you don't ever run into negative numbers. That's really the whole point of that. And it doesn't matter what you call it, 5,000, 5,000, 500, 500, 10,000, 10,000. But a mile, but a section is a mile, 5,280 feet. So if you're afraid of going over that, 6,000, 6,000 will work. It doesn't matter if you need to traverse from one side of a section to the other corner. You know, and if you start at one edge, you're going to want maybe a little bit bigger than that. It doesn't really matter. It's all relative to each other. So that's what assumed coordinates is, and then we're just adding. We're using our foresight azimuth, taking the cosine of that times the horizontal distance, and getting that up and away. We're getting that north out of that and adding it to there. We're taking our sine of that times the distance and adding it to the easting. Gives ourselves some new coordinates, and we're just going to keep doing that, and we're going to keep doing that. Now what we've done is we've taken our azimuth that were already calculated for us, and then we added the angles to that. But from now on, we're going to add the angles. We're going to do the angles like you would do normally surveying, and come back around and put in the angles, put in the distances, and then calculate the foresight, the backsight bearings, and the coordinates from that. And that will, and then you'll be able, we'll maybe draw a couple more of the orange rectangular boxes in there just so you kind of have that idea. All right. Well, I'll let you guys go, and I'll try to figure out how to get that off of there. I just don't know. I don't know. Well, thank you all. Hope you learned something, and please, please, please like and subscribe. All right.